Alkenes. Alkenes are unsaturated hydrocarbons containing double bonds. Unsaturated hydrocarbons containing double bonds. Okay. Its general formula is CnH2n. Okay. General formula is CnH2n. So example C2H4, C3H6, etc. are examples of alkenes. Okay. It contains a double bond. Okay. They are also called as olefins. Olefins because their lower members on reaction with chlorine and bromine, it forms an oily substance. Okay. Lower members form oily substances on reaction with chlorine and bromine. So they are called as olefins. Okay. Chlorine and bromine. So they are called as olefins. And also we studied that the hybridization is sp2 hybridization. And they contain a pi bond. This pi bond is due to the sidewise overlapping of p orbitals. Okay, pi bond is there. So in the case of pi bond, these electrons are loosely bound. As a result of this loosely bound. Okay. So pi bonds are electron rich centers. Electrons are loosely bound means these electrons are easily available for the reaction. So due to these pi bonds, these are electron rich centers. Okay, electron rich centers. So electrophilic reagents can easily come and attack this electrophilic reagent. So it is an electrophilic reaction takes place in alkenes. Okay, electrophilic, since it contains a double bond, electrophilic addition reactions can easily take place in the case of alkenes. Okay, next nomenclature we already discussed earlier. Okay, next isomerism. Isomerism in alkenes are two types of isomerisms are possible. Isomerisms like geometrical isomerism and structural isomerism. Geometrical isomerism and structural isomerism are seen in alkenes. Okay, structural isomerism we already discussed. Compounds like 2-butene, 1-butene, etc. Okay, we already discussed. Next, geometrical isomerism. Geometrical isomerism also two types of isomerism we discussed, cis and trans isomerism. Okay. In the case of alkenes, the compounds can be obtained are of different types. Okay. Either the substance attached may be of same types or all the substance attached may be of different types. Okay. We discussed the compounds like this. We already discussed. So compounds which possess geometrical isomerism, there is an important condition that it must have double bonds. Okay, such compounds only shows geometrical isomerism. Also, each carbon atom contains two different substances. Okay, such compounds can form geometrical isomerism. We can draw three types of such isomers. Okay. The third type is all the substances attached are different. Okay. X, Y, Z, W. This means that all the substances attached are different. Here the same substance on two sides. Okay. We already discussed these kinds of isomers. Geometrical isomerism possible are two types, cis and trans isomers. Okay. Please refer that so you can understand what do you mean by cis and trans isomers. Here we are discussing about the third type of isomers. All the substances attached are different. Okay. In this case, the isomerism obtained are of two types, E and Z isomerism. E and Z isomerism. Okay. In the case of E isomerism, E-isomerism means the higher priority groups, okay, higher priority groups of the two carbon atoms, okay, on the two planes are on the different sides, okay. Higher priority groups are on different sides. Such compounds are called as E-isomers, okay. Higher priority groups are opposite sides. Opposite sides are E. Okay. E-isomer. Take one example. Let us take one example. Say double bond C. If all the substances attached are 4 different halogen atoms, let us take that example. Okay. Here, take this fluorine atom, chlorine atom, bromine atom, sorry, iodine, bromine. Take this example. In this case, we can see that here the higher priority is F and here the higher priority is Br. Okay. These two higher priority groups are on the opposite sides. Okay. That means this is an E-isomer. Okay. If the higher priority groups are on same side, they are called as Z-isomer. Okay. Z-isomer. Let us take, we can draw the Z-isomer for this. C double bond C. Okay. F, Cl. If the Br is here, okay, this means that these higher priority groups are same side of the double bond plane, okay, of the pi bond, this plane, CC plane, these are on the same side. This means that this is a Z isomer. So these are the two types of isomerism seen if all the 4 constituents are attached are different, okay. This much about the alkenes. Next class we will discuss more about alkenes.